Go. We're going to talk about matrix equations. It's all going to kind of come together right now. Everything we've been doing with matrices on finding inverses and all that other jive and solving systems and all that fun stuff. This is another way you can do it, okay? So we have our system of equations right here. So we can actually take this system, and we did this earlier on in 6.1 where we took this system and we kind of put it into a matrix, but it was a little different than this. We didn't quite do it this way. However, we can look at this matrix, these system equations, into what's called matrix equations. So notice that these numbers right here are the coefficients of the variables. So this matrix right here is called the coefficient matrix. All right, it's called the coefficient because it's the coefficients of our matrix, or of our system. This right here, notice it contains all the variables. So it would be known as the variable matrix. And then this one right here is all of our constants. Hence, they're the constant matrix. All right? So that's all 33 kind of is talking about, is just how to organize it. And then 34 just again showing you that this one's called the coefficient matrix, this one's called the variable matrix, this one's called the constant matrix, okay? So what does that mean? Well, let's show you. So what we're saying is, look, if we have A times X equals B, we know that if we multiply by the inverse, these two will simplify. They'll become 1. A inverse times A is the same thing as 1, or the identity matrix, which means I'm left with just X. Whatever I do to one side, I have to do to the other. Now notice though, please note, this inverse is on the left. Notice how the inverse here is on the left. You got to keep it on the left. Remember, matrix multiplication is not commutative. So if you don't put it on the left, you will get the wrong answer. So you have to multiply by the inverse on the left, multiply by the inverse on the left. So therefore, X is equal to the inverse of A times B. You might be like, well, that's cool. So what does that mean? Well, if you remember correctly, we just showed you that here's our inverse matrix, okay, of this matrix right here. We took this matrix right here. We found its inverse. So we took this matrix and found its inverse. We just barely did that on the last video. And that inverse was this right here. If I then multiply that by my constant matrix, I get out the solutions for X, Y, and Z. We get out the solutions for X, Y, and Z. So if I take the inverse times the constant, that'll give me the solutions for X, Y, and Z. Let's do one and see if it makes any sense to you, okay? Here we go. All right, sorry. There we go. Now we're ready to go. So first it says, write this system as a matrix equation. Hey, it's a 2 by, this is nice, not a 3 by 3. We're going to be dealing with 2 by 2s here. So first we come up with our coefficient matrix. That's the ones that are in front of the variables. So 2, -5, 3, -6. We have our variable matrix next. X, then Y. So one thing to note as well, see how this goes X, Y, X, Y? You need it to go X, Y, X, Y, or else this isn't true. If you were to think about this, when I multiply these two together to find row 1, column 1, I would take row 1 times column 1. So 2x plus -5y, that's this right here, equals our constant matrix, which in this case would be 15. To find row 2, column 1, or sorry, to find row 1, to find row 2, if I multiply these together, I would take 3 times x, which is 3x, plus negative 6y, and that would equal 36. So we've now set this up with our coefficient matrix, variable, and our constant. What we need to do is we need to find the inverse of this guy so we can multiply by him. So to find the inverse of this matrix, do you remember what we did? The first step to find the inverse is we find the determinant. To find the determinant, we take 2 times negative 6, negative 12, minus negative 5 times 3, negative 15. Negative 12 minus negative 15, that equals 3. So then second, we take 1 over the determinant, multiply that to our mixed up matrix, right? Which means we're going to take and switch these two places, negative 6, 2, switch these guys as signs, 5, negative 3. So I get 1 over 3 times negative 6, 5, negative 3, 2. So 1/3 times negative 6, negative 2. 1/3 times 5, 5/3. 1/3 times negative 3, negative 1. 1/3 times 2, 2/3. So there's my inverse. This is the inverse. So I'm going to multiply here. So remember, if we call this A, then this is A inverse. So I'm going to multiply by A inverse. What I do to one side of the equation, have to do to the other side. Remember, keep it on the left-hand side. It's got to stay on the left-hand side, or else it won't be right. So these two give me an identity matrix, which leaves me out with just x and y. Now I have to take the inverse matrix, negative 2, negative 1, 5/3, 2/3, times my new matrix, 15, 36. So now I just multiply. So again, row 1. So this is a 2 by 2. This is a 2 by 1. They can multiply. Our new resulting matrix will be a 2 by 1. So if that's true, we'll have 2 rows, 1 column. So to get R1, C1, I take R1 times C1, negative 2 times 15, negative 30, 5/3 times 36. Well, 3 goes into 6, 12. 5 times 12 is 60. Negative 30 plus 60 is 30. Okay, row 2, column 1. Means I have to take row 2 times column 1. Negative 1 times 15 is negative 15. 2/3 times 36. 3 goes into 36, 12. 2 times 12 is 24. Negative 15 plus 24 is 9. So that means xy equals 39. So hence x equals 30, y equals 9. That's how she's done, folks. Hey, hope you enjoyed it. Good luck to you. We'll be around answering some questions, okay? Have a good day, guys. We'll see you. Bye.